ECE313. Okay, so we look at this and we say, oh, we've got one of those extended length fields. Okay? Because we know that the least significant byte of the delta time has 0 in its most significant bit. So that's this one. And we've got just one extra byte to tell us the time, the delta time. Okay? Does that make sense?
So the least bit, or sorry, the least byte, the 40 tells us what again?
Well, both of these combined tell us the delta time.
Okay.
What happens is you look at the first bit, because you know you've just decoded one MIDI command. You know the next thing is going to be a delta time. So you look at the first bit of the first byte of that delta time. If it's a 1, it means the next byte is also included in the delta time. So you go to second byte. Is it a 1? Okay, well then the next byte is also included in the delta time. And then you keep going and you keep adding these bytes to the delta time until the most significant bit is a 0. And then you say, oh, this is the last byte of the delta time. And then you take all those bytes, you strip off the first bit, and then you take the 7 remaining bits, put them together, and convert it. So in this case, we look at the first byte, say, oh, it's an 8. The most significant bit is a 1. We're going to take the next one too. Look at that, most significant bit is 0. Oh, okay, it's only 2 bytes long. All right, so now we take the 2 bytes. So this is 1, 0, 0, 0, 0, 0, 0, 1. And then this is 0, 1, 0, 0, 0, 0, 0, 0. Okay? So what we do is we take these 7 bits and we take these 7 bits and we put them together so they're one 14-bit number. So it's 1, 0, 1, 0, 0, 0, 0, 0, 0. Right? And then if you convert that into decimal, you get 192.
But when you say, wait, how did you convert? You don't stick them together?
You do stick them together. I'm sorry. I eliminated the
oh, okay.
the leading zeros.
Right.
So yeah, so you stick those two 7-bit values together, and you convert it to decimal, and you get 192. Now remember what I was saying was that we looked at this and we said 240 pulses per quarter note, 4/5 of 240 is 192. So I look at this and say, oh, okay, that's a quarter note. Okay, so once I got the note on and note off, I could tell it's a quarter note. So what's the next thing we get?
81, okay, and then 83
No, 83C is actually a note. So this is the delta time. Yeah, so you're right. This is 80 means note off, 3C with velocity 40.
Okay.
Right?
So
actually,
I figured the 3C would have to be off unless you hit the note again.
Exactly. Yeah, that's a good point. Yeah. 90 is on, 80 is off.
Okay.
For channel 0. Okay, so what comes, so all that combined, so it's actually the note off and the delta time tells you it's a quarter note, based on that rule I mentioned before. Okay, so the next, what's the next piece of data we get?
It starts with X30.
Mm-hmm.
30 that delta is not accurate.
Right. Yep.
And 30 after one of that.
That's 48. So remember, 192 on, 48 off. So that follows that pattern we were talking about where
Okay.
the duration of a note is 192 and the duration between notes is 48 for quarter notes.
Okay.
So again, so this, I just went through the file and started reading that, and then once I saw a number of these notes, I went back and I said, oh, this is what they're doing. You know, where everything that should be a quarter note I see is 192 pulses, and then between each quarter note I see 48 pulses.
Okay. So this person arbitrarily picked and divided
The person or the software? Yeah, I really don't know.
Probably the software.
I don't know where that decision was
Oh,
made.
yeah, the software, yeah.
Okay, so the next thing is the note off, right? So what is that?
40, it's, note off after, so it's another quarter note?
Yep, it's another. It's the exact same command we saw before. So really, what we've seen here is note on command, note off command, note on command, note off command. They're the same two commands repeated. And so again, it's another quarter note. Okay, and then it basically keeps going on like that. And here, let me hand that. I'll give you the decode. You know, we're on slide 2, and it's actually, I have it here in the presentation. I just kind of cut and pasted the text file. So, you know, here's our decode on the track that we walked through, and these are what I call the spoiler notes, is explaining at the 5x5. And then here's the decode. So again, here's our vocal, our choir, our vase. So our note on, note off after 192 pulses, another note on after 48, note off after 192, and then another note on for 48 pulses later. So now we're on the third beat, right? Because these first 4 lines tell you about the first 2 quarter notes. Now we're on the third beat, and we have another C3. So we've got, let me try and break these a little more compressed. So we've got a C quarter note, C quarter note, and then the third beat, we get another C quarter note, and then this is turned off 144 pulses later. So it's not a quarter note, this one, it's a dotted eighth, right? Because if it was an eighth note, it would be 96 pulses. And 144 is in the middle of that. It's a dotted eighth. Okay, and then we see, okay, well, then the next note is 36 pulses later, which again makes sense, because 36 plus 144 adds up. And so that's 140 pulses after the beat. So it's on the ah 16th note. Okay, so you've got beat 1, beat 2, beat 3. So it's 3, E, and then you got a 16th note on the ah. Okay. So that's D3, and that turns off after 48 pulses. That's how I know it's really a 16th note. I know the example, so I'm kind of writing ahead here when I write the note. And then what comes after that? Hang on a second, I missed something. Oh, let's see, the first beat. Oh, I'm jumping the gun here. I'm sorry. So there's the dotted eighth. So this is on the ah to the 16th note. Oh, and then D. So it's the 16th note. Fourth beat of measure 1 is an E, and that's a quarter note. Okay. Okay. You got it?
Yeah.
Yeah, I embedded the MIDI file now. Yeah. So that's your basic simple MIDI file, where you're going. For example B, I found another copy. This is a longer file. I'll give you that one. That's decoded, and I went through decoding it, and as soon as I got into it, I realized that it was not as straightforward as example A. Example A had this rigid 4/5 rule. Example B didn't. Everything was, you could kind of guess how long notes were, but it was very fluid. It wasn't a rigid rule.